So, hello everyone. I hope you can hear me well. Thanks for joining and welcome everyone to our 7th virtual AI meetup. My name is Marek Modrý, and as one of the MLMU organizers, I will be your host today. It's great to see that there are so many of you who found the way back to ML meetups after the summer break. But if this is your first meetup, just let me quickly recap the main communication channels that we use. It's mainly mlmu.cz, our website, Facebook profile. We also, and you most likely know this, have a meetup profile on meetup.com. And also we use Slack, where you can find various information. And also it's a recommended way how to contact others if you want to let others know about anything. Also, if you haven't heard of MLMU so far, believe it or not, this is, I believe, event number 90. There is AI community we organize in Prague, in Brno, in Bratislava, and also in Košice. So when we get back to live meetings, make sure you check our programs in those cities. And also let us know through email or our social network profiles if you have suggestions for any speakers, or you would like to join our team and actively participate in building the AI community, either in Czech Republic or in Slovakia. Before we start, let me also say that we are really grateful to our partners, which are Seznam.cz, Konica Minolta, SAS, Rosum, and Datacentrics, who are really helping us a lot with building this community, and without them, it wouldn't be really possible. But now to the main point of our meeting. Today, it's my great pleasure to welcome Vašek Košař, who will tell you more about serving ML models in the AWS using Python. You may have seen also some news already about GLAMI open sourcing their work on the project or library called Cortex. So make sure you check those news and the library also after the meetup today. And Vašek is a software engineer in GLAMI, where he works on AI product categorization and recommendation. Before we start, one last thing. You can ask any questions you want either here in chat, or rather use slide.do/mlmu, which is a website where we collect all the questions, and we will answer those at the end of the talk. But now I will pass the word to Vašek, and it's yours. I will let you share.
Okay, let me start sharing. Okay, can you see my screen?
Yes, thanks.
Okay, excellent. So hello, I'm Václav Košař, and I would like to tell you something about Cortex Serving Client, which is a Python package that we developed at GLAMI. It is a Python package for machine learning operations, for sort of DevOps or MLOps. So it deals pretty much with machine learning serving. So, and what is this problem of ML serving and machine learning operations? So let's say you have a model on your computer and you would like to deploy it to the cloud, for example, to AWS. And once you deploy it, you would like it to be accessible through over the internet through an HTTP requests, for example. So that's the serving part. And maybe you would like to also use the power of machines in the cloud that you can pay for just a short time and train your models there as well. And then, of course, you would like to have ability to remove your endpoints, scale them horizontally and vertically. So you may want to have more models, and maybe you would like to have them a little bit more powerful, a little bit more juice. So how would you solve this? So at GLAMI, we created this custom solution that works for us, and it is now open source and you can use it. It makes machine machine learning model, train and deploy automation to Amazon Web Services simple. It is a wrapper around a different open source project, which is called Cortex, which has this great command line client and does lots of things for you. But we wanted to access it from Python to have some sort of automation around it. So it's a wrapper with extra features. So we provide the basic methods which are implemented in Cortex, but we have also some additional sort of safety automatic removal. If your APIs exceed timeout, you can stream your logs into your local machine. And so far we are happy with this solution. We are always sort of improving it, but we have 2 projects running and made hundreds of deployments with it. You can, once you have this presentation, I think it will be shared later, then you can access these links over there if you're interested. So when I joined GLAMI, I joined to sort of work on machine learning projects. And first of them was to modernize an old product categorizer. Because we work in GLAMI, we have lots of fashion products, we would like to categorize them. And we needed to mainly improve the project's DevOps, because the project had stability issues and so on. So one day I was talking to my machine learning team colleagues, Tonda and Tradek. They are actually on the call as well. And they will help me answer your questions later. And they were sort of they were already there, and they were sort of telling me, okay, so you know, this project uses these low-level Docker commands, but we are thinking about replacing it with something simpler, with something a little bit more user-friendly. And we found this utility called Cortex, right? But it has only a command line client, so we would need to sort of have something around it to access it from Python. So I said, okay, guys, I'm on this, right? So yeah, of course, with lots of collaboration, I worked on this project and developed the solution. And we ended up reusing this package also in our recommendation engine, which we are working on now. And also we published the package to GitHub and PyPi, so you can consider using it. It certainly works for us. So what exactly is this open source utility Cortex, this command line client? So there are already DevOps solutions, right? For example, you probably heard about this Kubernetes thing, which is this, you know, very much, this is a huge open source project which has many distributions, and this is highly configurable, and you can make it anything you would like it to be. But we don't have too many people, and we are not so much familiar with this. So we wanted to have something simple. And so this Cortex project, it requires much less from you to know at the beginning. So it's much easier to start. You can do less, but for us, it's so far enough. So this Cortex is an open source command line utility that orchestrates for you actually this creation of this Amazon Web Services cluster. I'm going to hide this window. Okay, so it orchestrates actually the creation of your EKS cluster, which is actually a distribution of Kubernetes in the Amazon Web Services cloud. And it configures your auto-scaling groups and your load balancers such that your APIs can be executed from internet. So you can call your predictions from over the internet, and does this serving for you, creates your virtual machines and so on. And this is orchestrated by this Cortex open source project. So if you want to use Cortex, one of the first commands that you will use is Cortex cluster up, and then you would pass your cluster configuration. So, you know, Cortex to actually serve your APIs needs a cluster created where you configure what kind of machines you will use, what will be the maximum of your, how many machines maximum you would use, and how will the cluster be accessible, is it completely private or not, and so on, these kind of things. And then once the cluster is created, you as a client using command line interface, you access through a operator load balancer or a Cortex operator instance. So this is a small, I think it's T3 medium instance in Amazon Web Services. It runs inside of the Kubernetes, as I mentioned, but it's much simplified. And this Cortex operator then scales your instances. It creates sort of instances of your model, which are called APIs, and I will tell you shortly more about what it is. And then from the outside, it can be pretty much anything. Any computers can access over HTTP through your API gateway, where you can have your HTTPS configured. Cortex project has lots of nice documentation how to do this. Then through load balancer, you get your requests load balanced on your models, on your instances of your models. So this Cortex API, what is it exactly? So it's a primary abstraction of Cortex, and it has to create an API, you need to have a Python module implemented with your model. That's the model that you, at the beginning of the presentation, was this computer. You have this model on your local machine. So it's implemented in Python. It's a Python module. And then to access this module, you have you need to implement this class called Python predictor, which here on the top right needs to have two methods implemented. Very simple. Just initialize your model in the init method, and then to execute predictions, the predict method will be called with your JSON payload as a dictionary, Python dictionary, and then you can do some sort of prediction on your model. And then that's not enough. Right? You need to have also, this information about how will this application behave in the cloud. So you need to have this YAML file where there will be name of this model, this API. You need to have your scaling configured, what kind of computational resources you want to have, and these things configured over there. And then, as I mentioned, it's a command line utility. You would execute Cortex deploy, pass your YAML file, and once this is executed in your cluster that you've created previously, you sort of monitor what's happening by Cortex get dummy API. So you refer to your API by its name. So as I mentioned, we've implemented this project Cortex Serving Client, which is a wrapper around this command line utility, because we didn't want to every time we didn't want to execute manually this command line interface commands. We wanted to access it from Python. We wanted to have some automation such that we can implement some more complex methods. So you would like to you'd like to update this API with the new model, and then maybe you would like to roll back this model because the new one doesn't work, and so this Cortex Serving Client that we've published, it's implemented in Python, and the original Cortex command line client is implemented mostly in Go. I think there are some other parts as well. Okay. So what Cortex Serving Client actually does? So as I mentioned, it wraps the Cortex client command line interface, but apart from the basic methods, it does a couple more things. So instead of using YAML files, now you can use a dictionary, of course, and you can as well stream your logs from the remote into your log, and you will have them quite nicely formatted. So the thread name will correspond to the name of the API over there in the cloud, in the AWS. As well, we have this sort of safety feature. We wanted to make sure that we will not that we will not have these huge bills. You know, you've heard about this banana skin in the AWS, right? Where if you forget some huge instance running, you will get big bill. So we can prevent this by if there are some transient applications, we have a timeout, and if the API is still there, it will get deleted no matter what after the timeout, and the bill is not happening. And yes, of course, it's for automation. So you can implement functionalities like the mentioned rollback. The new version of the model doesn't work, so I would like to immediately have the previous one. So how we use Cortex Serving Client. So we have this simple architecture that we call model manager architecture, where basically here's a product categorizer project on the right. And for example, you can be a user or super user of this project. So you can execute some high level methods like rollback or deploy or train over HTTP to your manager. And this manager is running all the time in the cloud on small instance. It is a Python project and it contains Cortex Serving Client, and then Cortex Serving Client controls your cluster, and it does what you've configured, what you've implemented. It performs your automation. And yeah, of course, there's some state. So Cortex Serving Client now stores the API timeouts in the Postgre database. And of course, the predictions, those actually go straight to AWS. So it doesn't have to go through the model manager, but yeah, theoretically, it could go through as well. Right, so we have both projects, categorizer and recommender, using this sort of architecture. We use this watchdog, this sort of model manager. Okay. So now I will show you, a little bit more hands-on demo. I will tell you, I will show you an example where I will execute some sort of automation, show you the Amazon logs, hopefully everything you would like to see. So, okay, let me switch. Okay, I will need to increase the font, right? I hope it's visible. Right, so I have this simple example. I have some logging over here on the top. Here I import get Cortex Serving Client instance, which will give me a singleton instance. And I need to tell it, okay, I would like to run this in AWS and not on my local machine. And Postgre database to keep my API timeouts stored sort of in the database. Here is my deployment configuration. So I will pass it name of the API, which is dummy API. I have a predictor, which is of type Python. So Cortex actually supports more types of predictors, and but I'm using Python. Then I pass a path to my Python predictor, and I will configure very small computational resources to be dedicated. And I have a temporary deployment here. So I have a little context with during which a deployment will be available in the cloud. So I will, so this with method executes deploy temporarily method, to which I pass the YAML, well, the dictionary. I will inform it where is where is my model located. I will configure timeout. So if something happens, but the Cortex client keeps running, it can remove the instances from the cloud. And I will print logs locally. And within this context, I can run my prediction. So I will execute post request on the endpoint that I will get from Cortex get. and I will pass a JSON, which will contain question, do you love MLMU? And then I will get the JSON back. And I will check the results. So just a second, what is the predictor? All right, so the class Python predictor, as I showed previously, so it contains this initialization method where I initialize my model, and this prediction method where the model predicts something. But here I just return a dictionary with the original payload, and I set yes to true. So I can execute this. It's live, right? So let me increase. So what's happening now? Okay, so Cortex did some garbage collection at the beginning. Nothing was in there, so nothing happened. It's starting deployment API timeout 1200 seconds. And now it started, Cortex started getting logs, and it's giving the logs the thread name API dummy API. So that's the name of the service. So API underscore, right? And so what's happening in the model, I will track this thread name, right? So I should see, oh yes, initialized model. So this, the line that I showed you previously was executed, right? This initialized model. And then, but that's there, over there in the cloud. It's not local. So, okay, so what more do we have here? Okay, so it started UVcorn, and then it executed predicting. And once it was finished, it deleted the dummy API from the cloud. And the result is printed. So the answer to the question, do you love MLMU, is yes. Wow, wonderful. Okay, so what do I do? Once more, I can check. So now I execute the command directly, Cortex get. Okay, no APIs deployed. So it was cleaned, wiped clean, right? So, but you would like to see what happened in the AWS, right? So, okay, so I'm in my location Ireland, and okay, auto scaling groups. So somewhere over there. Oh yes, here I get this. So I have this EKS cluster Cortex Serving Client test. So this is the name of the cluster. And here's a worker spot. So that's auto scaling configured for the worker spot. It was created automatically for me during the creation of the cluster. So that was not part of the demo. And then I have the Cortex operator. That's the one that keeps running there all the time, listening for my commands. Right, so what about load balancers? Where do we have this? Okay, here they are. They were hidden. Oh, that was dangerous moment. It almost didn't work. So okay, so I have two load balancers, right? And they have some crazy name, but we can look at the tags, and what do we see here? So the service name for this one, okay, it's some ingress gateway. Okay, it doesn't tell me that much, right? Cluster Cortex, oh yeah, cluster Cortex Serving Client test. So that corresponds to my cluster. Okay, great. So I think this is a API. This is a load balancer, which load balances over my API. So it has some sort of, if you configure it fully, you will have some HTTPS domain and slash. After that, you can call your API names and post your HTTP requests. But I did that all from Python. All right, what's the second one? Okay, the second one, ingress gateway. It should have somewhere in the description. The second one should be operator. I'm not sure where to check it now. So one of them is worker, the second one is operator. I think I saw it somewhere, but I don't see it now. Okay. All right, so yes, of course you can have some volumes, but I'm going to go to CloudWatch. Can I see my logs as well in the cloud? So of course, our APIs, because they are part of the cloud, they log into their corresponding log groups. So here I have a log group for my cluster Cortex Serving Client test. And here's a Cortex Serving Client test / dummy API. So that's a log group for my dummy API that just ran over there. Okay, so the last time, that should be now 1626, it's UTC, so that seems to fit. And over here, if I click through, I can see my initialized model and predicting. Nice, very nice, very nice. Okay, going back. Okay, if you would like to try this for yourself, you can try it at home, actually. And you can click through this link to GitHub and see if you can run that example Pi as well. So, okay, I will present rather. Okay, so get the client, but you know, I will slow down a little bit more. You know, there is actually alternative. It's called Bento ML, and I think you should have a look at it and maybe compare the two. But for us, Cortex is an opinionated end-to-end solution. So we sort of prefer it, but we haven't done actually that much testing, I think, for the Bento ML. But from what I've seen, I think Cortex is much simpler. And yes, this is already proven and simple, our machine learning operations, so we won't be switching anytime soon. You can get the Cortex Serving Client at GitHub, right? Or PyPi, Cortex-Serving-Client. And yeah, did I mention GLAMI is hiring? And we are looking for, of course, ML engineer, you know, standard stuff. You can join the awesome team. It's comprised of Antonín Hoskovec, you know, expert in machine learning, many years, amazing guy as well. And he's on the call, so he may be answering some questions. And there is also Radek Bartizal, also on the call. It's very good at recommender systems. So I think we will have very solid project out very soon. And of course, that's me, Václav Košař. And yeah, I'm still sort of progressing into machine learning role, but I already know thing or two. So you can join this team, but also we are looking for a senior PHP developer in GLAMI, in Liberec, backend developer, frontend developer as well in Liberec, and other listings. You can go through this wormhole to all listings at startup jobs. Okay, thank you very much for your attention. And if you have any questions, we are ready to answer them. I will stop sharing.
Thank you, Vašek. Let me share my screen with the questions. So hopefully you can see the screen.
Yes.
Yeah, so let's start with the first one. What advantages of Cortex compared to AWS SageMaker deployment? We are developing models in SageMaker already.
Okay, nice. So I haven't done too much research on the SageMaker. I think that was, it had some kind of transient nature. I think Tonda might know more. Do you, Tonda, are you?
Yes, sorry, I was looking for the unmute button. We needed a simple GPU support. And at the time, SageMaker was quite difficult to force into GPU support, just based on some dependencies that we wanted to have there. Cortex allows you to have custom requirements installed, and it creates the Docker image for you and starts the containers. And they worked with our dependencies, but in SageMaker, we had the issues with the dependencies. So that was the reason, yeah.
Thanks. There is, I will just skip quickly. There was a question whether this will, whether this whole meetup is recorded and whether it will be available later on. The answer is yes. So another question is, can you explain a bit more, or again, how the garbage collecting works? Thanks.
Yes, I can. I'm thinking about showing a code, but I think that would be too much. So what it basically does is that when you get your Cortex instance, once you initialize the singleton of the Cortex, there is a loop which keeps sleeping from time to time. And this loop monitors what is in the database table corresponding to Cortex. And if it sees some sort of inconsistency between the table and what's deployed in the cluster, then it will make the correction, so it can delete from the table, or you can delete in the cluster, and it would show warning and so on. But the canonical case of when this when you have something running too long and you need to delete it, for example, you have some prediction running for too long and you would like to end it. Maybe you are training your model in your initialization method. So in that case, one of those executions of the garbage collection, the algorithm would see in the database that the timeout already happened for the API, and it would get deleted. It would execute, Cortex, delete this API. Yeah, I hope that answers the question.
Okay, cool, thanks. So the next question is, have you seen any issues with Cortex, stability, security, bugs?
Well, I think we didn't have, I don't remember any major issue. We were missing some security configuration, but since then they've implemented what we needed, so you can keep all your services private within the cloud. And anytime there is some kind of issue or we don't know how to do something, there's actually a Gitter for the project where you can contact the developers, and they are very, very responsive. It's a startup in Silicon Valley, and they are just 2 guys now, but they are so responsive. They are really fast developing this, and they are thinking about hiring more people. We actually had a call with them, and they were sort of interested, what we are using from Cortex, how we are using it, maybe thinking about pulling some features into the Cortex in future. And so I hope that answers the question.
Mm-hmm. Thanks. The next one is, have you tried to deploy some bigger models, something more complicated, maybe something with GPUs?
Yeah, definitely. Our categorizer, I'm not sure how secret is it, but it's obvious we use images of the product for the categorization. And so for that, you need large networks, and you need a GPU to actually run it fast enough. So we do use GPU, and I think we have quite large models. I think it's not amazingly big models, but we have large models, and you can spin up huge instances over there, actually very powerful machines in the Amazon Web Services. We use this G4P, I don't remember, D4, D2,
Yeah, cool, thanks. Perhaps just a quick side note, I'm not sure if you mentioned what GLAMI actually does, because I'm not sure that the audience is a typical user at GLAMI.
Oh yeah, sure. So GLAMI is a fashion search engine. So you would be, for example, looking for a shirt or sandals with socks, right? So something like this. And so you can do that on GLAMI, and it will sort of search e-shops for you, and it will display relevant results, and you can select it. It has some catalog, which is nice, hopefully nicely categorized, because that's what we are trying to do well. And yes, so that's it. Fashion search engine.
Okay, cool, thanks. What are the use cases GLAMI is using this for? Might have missed. Sorry. So I guess that I have just asked. Yeah. So I don't know if
so we are using it for the recommendation engine as well, which is coming up. So we will personalize exactly for your sort of needs. Yeah, it's not that uncommon feature, right? But it's coming. And we also do this categorization of items because each shop has a different, categories and so on. We need to have some order in the catalog. Yeah.
Cool. Thanks. Does Cortex offer some basic rate limiting of the API? Is it safe to provide the API externally?
Okay, rate limiting. So you can configure scaling. So you can, I would like to have per instance this much, right? And then you can limit maximum amount of your instances. So if you would sort of multiply this number of requests per instance until you get another one, and then at one time you will run out of all your computation because you will reach this limit maximum number of instances. So yes, I think you can use it as a rate limiting.
Yeah, but if somebody tries to DDoS you or something like that and just like sends you incredible number of calls, API calls, then
per API. Okay. Yeah, sorry. I think they probably.
So
there may be something in Amazon Web Services,
yes,
because it goes through gateway, and there may be something there.
Yeah, Cortex client or Cortex, it creates for you an API gateway if you want to, and then you can find it in the AWS console and configure anything that the API gateway supports. I think rate limits are there as well.
Okay, cool, thanks. Question from a noob. Does this also include the training phase of the model? If so, can you do standard stuff like hyperparameter tuning or cross-validation?
Well, it's an amazing question. So I don't think it comes from a noob, but yeah, sure. So as I mentioned, all the API, it was for prediction, right? So it's a very smart question. How do you do training? So at the beginning, we needed to do simple trick. So we are doing it still. We are training our models as part of the initialization of the API, and there may be other way to do it. So you can sort of probably create a thread on one request, and then on the second request you can check if it's still training. So you can do training, but they recently released this feature because we are asking them about this, so you can see how they are responsive. So it's a batch prediction, I think they call it, and that would be probably more you could do more easily exactly this, and yeah, we may be using it in the future. So you may see it in the Cortex Serving Client as well implemented. So yeah, you can do it, and from the I think version 19 or 18, you can do it even better. Yeah. This batch prediction, I think. Cross-validation, hypertuning, I think that's part of the. You can do it. Yeah, of course, you can probably do it as part of some loop, as part of the train.
Yeah, it's also one of the reasons why we moved to Cortex as well, because we didn't want to have two dependencies. Like we didn't want to depend on one service for training and then on another one for prediction. This way, we create one cluster with GPU instances, and then we just send a request, and some of the instances are training models, while the other are predicting on models that were trained in the past. So. That was one of the key features why we moved to Cortex. We tested, this simple trick, and it worked.
Thanks. Next question is there support for training bigger models on multiple GPUs? What about implementation with Horovod or training with distributed strategy?
Okay, so I think you probably can do multiple GPUs. I'm not sure, but about the distribution, I'm not sure if you can do it this easily. I don't know. Do you know, Tonda?
I haven't seen it used this way. I think it should be possible because it uses the NVIDIA Docker for running all the GPU models. So, you know, I think you could implement it in the model code in Python, but you know, you would have to do it yourself. There's no way to like automatically submit this. But I think it should be possible. I haven't seen it though.
Thank you. The next question is, what is the advantage to use PHP on the backend instead of Python, as you present on the GLAMI is hiring slide?
Yeah, sure. So I think PHP is it's, you know, that's a code that the GLAMI started with. So lots of things is in the PHP. So I think that's the main reason why PHP is used on the backend. So we don't use it as part of the machine learning team, but you know, other parts of the company are, you know, using it. I don't think it would be easy to just transfer all the code to something else. So yeah, that's the answer. But yeah, I think it works. I think Facebook, at least very long time, ran on PHP. I'm not sure what they do now.
It's still the leading backend language, I think, at least on GitHub and you know, the public sources.
And I think they made it actually fast. I think it's faster even than Python because how they compile things.
Yeah.
So that's it.
Thanks. And then it seems that we have a last question from Joseph. Are you implementing any pre-processing and post-processing code directly in Cortex code, or keeping pure machine learning code in each instance?
Well, I would say we don't do that much pre-processing or post-processing, but you could say we do it as part of the module that we deploy into the Cortex code, which is part of this Docker image that is then scaled. We do everything we need there, but yeah, our services are not are not public, so we probably don't do as much pre-processing that it may be common.
Yeah, it's done as soon as the data set is downloaded and then processed. Yeah, it's part of the code that runs on each instance. We don't do it through Cortex. Yeah.
And we have one more question. I like this one. Is there a possibility to find NIST example deployed via Cortex, something very easy so we can get fast grasp and reuse it as fast as possible?
I think they have something like this on the Cortex documentation page. I think there are several projects there, so you can have a look there. And if you need to access the Cortex through Python, then you would think about using Cortex Serving Client. But on the Cortex documentation.
Yeah, and the GitHub repositories as well. Just go there and yeah, the examples are there for both.
Awesome. So it seems we are done with the questions. So let me thank you, Vašek, and Tonda, and also Radek for the talk and for the answers to all the questions. It was very insightful, and I believe that yeah. So this recording will be definitely available later on, and I will ask Radek and the team to provide all the related links to their work on the Cortex Serving Client and also other related stuff. So we will add it to the description of the video and share it with you later on, so that you can check also their repository, which is also, I guess, really easy to search for if you just enter GLAMI, GitHub, Cortex or something to Google. I believe that I found it myself this way. So yeah, Vašek?
No, it's okay.
Yeah, okay. I thought that you wanted to add something. Okay, anyway, thank you once again. It's great to have you here. And now this is not really the end of the meetup. I guess if you still remember the in-person live meetups, you can remember this, let's say, networking session when you actually could talk to people and meet live people and not only avatars or something. So this is something we try to simulate here with something that's called breakout rooms in Zoom. So if you want to follow with some like discussion with others on the call here, we will start just briefly in a minute or so. We will randomly, or Zoom will randomly split us to smaller rooms of about 5 to 6 people, where we can like network as we are used to, and yeah, and that's it. And once there is, let's say, less of us, we will somehow manage or restart the rooms so that we balance the numbers and so on. But I hope you will use this opportunity to talk to other, let's say, fellow AI enthusiasts, and that we will see each other in the breakout rooms. So just in a I don't know, 10 to 20 seconds, we will or you will see a prompt in your Zoom saying that you are going to be forwarded to the breakout room. So just click yes, and it will take you there. Sometimes it's tricky to find the prompt, so click around the windows and try to look for it. So let me just set this up. Yeah, so here we go, and yeah, and you should already see the prompt somewhere around, so look for it.